Please welcome from CoreOS, Euan Kemp.
Hello, everyone. Hello. Thank you for coming to my talk. My talk is Wait, My Net Does What?, which is a talk about systemd. I know the title's a little sensationalist, but when I say my init, I mean systemd. And when I say systemd, I don't just mean my init, because it turns out systemd does a lot of other things. This talk is going to be talking about those other things systemd does. I'm assuming that you know a little bit about systemd and journald already, but this is going to explore some other things that maybe you don't know about, maybe that you're going to learn that you can use. I'm also going to touch a little bit on the controversy around systemd, because I think that that topic relates a little bit. I'm also, everything I say is in all good fun. I really like systemd. I'm a big fan of it. I will criticize it occasionally. My first criticism is if you look at my title slide, it doesn't have a pretty image on it. The reason for that is systemd doesn't actually have an official logo or mascot, which is probably one of the biggest failings of the project, honestly. All good software projects should have a nice logo. For the purpose of my talk, I'm pretending that systemd, in fact, does have a mascot of a sock puppet. This is sockd. It's not accepted by anyone else, I don't think, but it's something that I personally like. So now that I've introduced systemd, let me introduce myself properly. I'm Euan Kemp. I work at CoreOS. I'm a software developer. I work on the container Linux team. I've done a little work on Rocket in the past, which is why I have that logo up there as well. Both of those projects use systemd very heavily, and this is part of how I learned about systemd. Container Linux in particular relies on systemd as one of the most important components of it. I say that, and you might ask, how do you actually measure that? I actually tried to see. It turns out that by some metrics it's not so important, like it's only 2% of the disk image size because it's a small package. Its version number isn't actually the biggest of every package we ship because less is a little bit bigger. However, it is PID number 1. It's obviously the most important in that metric. It's also over half the processes running when you first boot a machine, so it's important that it does a lot of things there too. So I said it's PID number 1. Well, that's because it's an init system, and an init system has PID 1. It's kind of a tautological thing. An init system also does a few other things. I'm not going to define it too closely because you probably already know more or less what init systems are. This is the technical boring definition. There's also a different, less technically correct definition that people started to think of for init systems, like what you use for service management. It doesn't really matter which definition we use because it turns out that systemd does all the things, so it fits all of the definitions. It's wonderful. Speaking of doing all the things, systemd historically has had a little bit of controversy around it, which I'll touch on very briefly. It was released in 2010 by Leonard Pottering. At this point, it wasn't controversial, which is probably because it had basically no users. It turns out when you have no users, you have no controversy. It's a nice little thing. Unfortunately, a year later, systemd suffered from a problem of having users. Fedora adopted it. It started to become somewhat known. And shortly after Fedora adopted it, it introduced the journal. The journal was its replacement for Syslog, which included binary log format. This is when the controversy really started. People started using it with Fedora, and then people noticed that they couldn't grep their logs anymore. And that was counter to the Unix way. This was clearly a problem. Unfortunately, people took it a little further than just criticizing the software, and in fact, Leonard Pottering was also the subject of quite a bit of criticism. He was vilified for his role in making systemd. He's also perhaps well known for his role in making Pulse Audio, and it turns out the Linux community said quite a few mean things. They implied that he was part of shadowy organizations. They implied that he was part of a Tea Party open source cabal trying to make Linux worse. It was absolutely ridiculous, I think. This all peaked around 2014. In 2014, this is when Debian finally decided they would use systemd. At this point, almost every distro had picked up systemd of the major ones, except for Debian and Ubuntu. Of course, there's the other ones that we know, Gentoo and Slackware, but regardless, at this point, Debian was considering it, finally accepted it, and controversy really came to a peak there. This is a graphic that was made in that time. It was a graphic that showed systemd has all these features it's been adding. It's eating all of this classic software that you as a Unix administrator know and love. It does cron, it does add, it is starting to integrate with dbus. There's all these things that it does. And I saw this graphic. I'm pretty sure it was meant to detract from systemd, but when I saw this, I actually saw it as a kind of, wait, cool, systemd can replace cron too? And I went out and I figured out how to replace all of my cron jobs with systemd, and I found out it actually had a better interface for me at least, and that it ended up being a nice little package. And my answer to basically the systemd controversy is that overall, it has been replacing things. It has been making all these it's been doing a lot of things that people say, but ultimately when it's replacing things that are crufty old Unix utilities. You can still use them if you want, but when the distribution maintainers choose the systemd alternative, or the users choose them, that's because systemd made them better, made them with better documentation, a better user experience, or so on. I actually was inspired enough by this little graphic that I have my own little sock puppet. And part of this talk, I'm going to be talking about things that systemd replaces, and whenever I do that, I'm going to motion that systemd has eaten one more thing, because this for me was really an inspiring moment in learning about systemd. In part because of this, I've been keeping track of systemd's changes to see what else on my system I can do in this new and better way. So the remainder of this talk is going to be talking about specific features of systemd that I find cool, or maybe a little bit weird, and in some cases that you can use to replace some of your existing things. The first thing I'm going to talk about is the features of the init daemon itself. So the init daemon, obviously a core part of systemd, doesn't actually have that many crazy features to talk about that aren't covered by later bits. But one really cool feature it has is socket activation. You might have heard this before. Some people have called it a buzzword, but it's actually, in my opinion, a quite cool feature. A concrete example of what socket activation is the Docker daemon on the Container Linux distribution. We ship the Docker daemon as a socket-activated unit, which means that when we start Container Linux, Docker isn't actually started. It just ends up having systemd listening on its behalf and waiting for when the first request is made. That means we can start up the distribution quicker, because the quickest way to start something is to not start it. And then as soon as someone makes a request, it starts Docker as you need it, and it passes the request along. And the user doesn't see anything failing. It just seems to be a little slower at first, and everything ends up being quite happy. This was something that inetd used to do in the past. Systemd has totally replaced it at this point in that no one really uses inetd anymore. I totally recommend using socket activation if you have long-running services it fits for. Some things do, some things don't. The next thing I want to talk about is the systemd user interface. So systemd not only runs an init daemon, it actually runs a user version of itself, which runs as your user. You can interact with it without root privileges, without any special privileges, and you can start services, you can manage services, and you can do a few other cool things. So this is a really cool feature to replace things like supervisor-d and perhaps other similar management daemons you have. One other cool thing you can do is often replace, if you have in your bashrc or zshrc a place where you're spawning a GPG agent or you're spawning an Emacs server or such. You can usually run that with this as well and end up with something that is quite a bit easier to maintain and often quite a bit quicker to start. So I have a set of terminal recordings. I'm going to skip some of them for time reasons. I'll play others. This is the important screen where you can see that you can use the system control -- user command in order to interact with this unit file that you've written into the special local user directory. One other cool little feature I want to call out here. This is a tiny quality of life thing, but if you use system control -- enable, you can also type -- now, which both enables and starts something at the same time. I didn't know about this flag for absolute ages, and now that I know about it, I use it all the time. Pretty much every time you want to enable something, you also want it to be running right then. So the next feature I'm going to talk about is one that you actually absolutely should not use, in my opinion. It's actually possible to run systemd pid1 init, the actual init daemon, as not pid1. This is a image from a real machine in the wild. The Google container image used to do this. It's running pid1 as upstart, and then the next pid under that is systemd. It's like someone at Google said, well, we need to pick upstart or systemd, and someone else said, you know, why don't we just do both of them? Seriously, though, you shouldn't do this. Systemd recommends against it, and it's honestly not a good idea for a couple reasons. The next thing I'm going to talk about a few features of, system control. You've probably used it to start and stop services at least, but it can actually do another few cool things. This is another kind of quality of life feature, which again, since I've learned about it, I've started using constantly. If you're familiar with the idea of drop-ins in systemd, they let you override small portions of vendor-provided unit files. System control edit will just drop you into an editor at the correct location to make a drop-in for some unit. And it seems like it's not that big of a deal for it to do that, but I don't know. It's been a really nice quality of life thing for me. This is a wonderful way to edit units on Container Linux or pretty much anywhere, because when you use it, it will correctly put you in the right location. It will make sure that it's there correctly. the other thing you can do is you can use system control cat to print out the unit and the drop-ins, which is another handy thing that you might already know about. So the next cool thing I want to talk about is another thing that you probably shouldn't use, system control -- host. This flag, the -- host flag, exists on many of systemd's utilities. What it takes is something like an SSH argument. You say, for example, root at demo here, which is saying I want to run this system control command, and I want it to actually affect the host demo instead of my local machine. This ends up being kind of like Fleet. If you're familiar with Fleet, this is almost the same, but we don't get to actually eat it because this is far less useful. One of the problems this has is the system control binary you're using is going to be your local version. The system you're interacting with can be a different version. Another problem it has is it only can interact with one host at a time, and if you're trying to do automation with hosts, you usually want many. You usually want something like, I don't know, Ansible, or in the case of Fleet, something that actually does do every one of those hosts at once and can actually manage them consistently. So this is a weird little feature that exists in many of the systemd flags implemented way back in 2011, and I've yet to actually find a valid use case for it in any of my systems, but cool to know that it exists there. Next systemd feature that you might or might not know about, systemd run. Systemd run is a really nice little utility for creating transient units. A transient unit is just a unit that will only exist at most for the lifetime of your machine. You reboot and it's gone, lives in a temporary directory. They can also vanish more quickly depending on if they complete and how they're configured. In this case, I'm going to show how you can use systemd run to entirely replace at. So if you're familiar with at, it's a traditional Linux utility that lets you just say, in some duration, I want to run a command. In this example, we're running the date command in 1 minute. We can use @q to view them. We can use @rm to remove them. So this is a similar sort of command, a systemd run one, where I say on active 20 seconds. That 20 seconds just says in 20 seconds, run this. And it's basically the exact same thing. I can use system control list timers to see the timers that are going to run, just as you could use @q. And then finally, we'll see that they both ran successfully. In addition to being able to just use like on active to say in this many seconds, you can give full calendar expressions. You can give it something like, I want this to run daily, or I want this to run at this exact date and time. You can give it all sorts of complicated expressions there. Those two things together easily eat at. You can also, however, use this, the timer units that it's writing, to replace cron entirely. This is the way you replace cron, is by writing timers yourself. You don't use systemd run to write them, probably, but this is the same sort of idea. You can also, if you use the -tty flag, completely replace screen with it, which is a nice little benefit for me. So the next thing I'm going to talk about is the journal, the wonderful systemd journal. So as I said before, it replaces Syslog. One of our Syslog's features, though, that it didn't replace at first is the idea of being able to upload logs remotely. So this is actually one of the features that systemd has built into the journal since then, and it's actually quite nice to use. It supports both push and pull model. So in this example, all I'm showing is that if you enable the systemd journal remote service on one thing and then start watching your logs, and then you launch another machine, you SSH into that second machine, and you, one sec, tmux, and on that second machine, you run the systemd journal upload service. Those two services together, after you configure them to talk to each other appropriately, mean that you can easily just write logs on one machine and see them on the other. You can have one machine that aggregates the logs for an entire cluster of machines. In this example, we use systemd cat to write to our local journal, and we see that, in fact, almost immediately appears on the other machine. This is actually quite handy for small clusters. I would like to say that this makes it entirely replace our Syslog, at least for my use case. It also can sort of replace fluentd in some cases, and it can replace certain other log aggregators. There are a dime a dozen, certainly, nowadays, but systemd provides a very nice integrated way to do that. One systemd feature that is also really nice with the journal is that it actually adds a lot of security over Syslog. You might not be aware, but under Syslog, you could almost always, with every implementation, spoof a log message as any other process. You could say, I'm Apache, and then write something. For things parsing logs, that can be quite scary. The journal, however, actually authenticates messages. It makes sure that they came from who they said they are, and anything in the structured data it logs that begins with an underscore is guaranteed to be as correct as journald can make it, which is usually pretty good. You also get certificate auth for the remote thing, which I just said. You get one other security feature, and this is the one that I'm going to say is a little bit on the more unusual side. You get something called forward secure sealing. I mentioned forward secure sealing mostly because it has one wonderful feature. It has the ability to make systemd print out a QR code. When you set up keys, which is the way you turn on forward secure sealing, you get this beautiful looking QR code. It's amazing that they made this wonderful terminal printer for that, but everything else about it, to me, I'm less sold on. It only secures your logs in large time slices, by default 10, 15 minutes. And then that means attackers could modify your logs locally, and then you can only verify your logs have been modified by taking this key you got out with the QR code and coming back to your machine later and actually doing a manual process. It ends up basically being, I don't want to ship my logs off box, and I want the best you can get locally, but the best you can get locally just isn't good enough to be worth doing it, in my personal opinion. All the same, the QR code, absolutely amazing. So at this point, we're on to some of the other features that systemd has. Systemd has replaced quite a few other utilities. If you're familiar with the abort utility, systemd has entirely aided it at this point. Abort lets you log all of the core dumps that happen on your box in any process whatsoever, and systemd lets you do the same thing now. You can just use the systemd core dump utility, core dump control, to view your core dumps and see what's there. It also has a couple other nice things that you can use it for. So here I'm showing, I can list that @d has crashed in the past, because I was doing a demo with @, of course @d crashed. I can look at it and see that there's a little stack trace here. It actually gives me a nice little bit of info. And then one really cool thing I can do is I can type core dump control GDB, and it just drops you into a debugger with that program with the core dump that it had there, and I can look around and see what actually happened. It's sometimes enlightening to type core dump control on a machine that you haven't been on for a while and just see this long list of stack traces, because things occasionally crash and systemd restarts them and you never notice, and then you have this long set of core dumps. So something else systemd has started to tackle. After it added the core dump utility, it added networkd and resolved. Networkd and resolved are a combination of a DHCP and DNS server. They are DHCP and DNS client. It's technically also a DHCP server. It's technically also a DNS server, but anyways, that's besides the point. They added all the basic features you'd expect, like IPv6 support, LDP, all these other things, and honestly, this is probably the biggest undertaking systemd's made since the original init system. We get to eat all sorts of things. We get to eat DH client and every other DHCP client, pretty much. We get to eat bridge control. We get to eat LDPD. We get to eat a few other things as well, in that it's a DHCP server for your container, which is a thing some other containers runtimes have shipped as well. This is one of the most monumentous undertakings of systemd, I think, in recent times, and it's absolutely amazing. Unfortunately, it's not all that interesting to talk about or demo, because it all just basically works, and it's a bunch of network files. What do you want to see? So systemd also added timesyncd. Did you use NTPD? You don't have to anymore. Timesyncd is an NTP client. There's really nothing else. It's cool. And now we're to the most recent thing that systemd has added. Systemd has added a bootloader. If you've ever typed boot control, then you'll probably see a small list of EFI boot options, EFI boot options, which will only apply if you're using EFI. This actually is only an EFI bootloader. It won't replace Grub yet. It won't replace Lilo, because those manage far more than just basic EFI boot. However, it's still quite nice. It's also something that can replace Refined, if you've ever used that, which is another EFI boot manager. It has some overlap with Gummy Boot in that it literally is the Gummy Boot code, but copied into the systemd code base. The maintainer was totally okay with it. It just got merged over. So one other comment I want to make on this, though. Let's look back a second. We started talking about systemd as this thing that manages your process. It's an init daemon. It's a service management daemon. And that's all it is. And where we just got to was systemd managing your kernel, managing the boot of your kernel, controlling EFI, running right before your kernel, and then after your kernel runs, running right after. Kind of a big jump. I'd like to point out one other thing, though. All of these things I've mentioned, with no exceptions other than systemd and sort of journald, are things that you don't have to run. This is kind of tying back to the controversy thing, but every single one of these things, you can adopt them if you want to. You don't have to. All of them are backwards compatible to a large degree. Journald, you can still run rsyslog, varlog messages is still there. Systemd itself, you don't really get backwards compatibility, but everything else, networkd, you can still run network manager, et cetera, et cetera. Your bash scripts that ran bridge control will still work if you really want to run them. But anyways, so we've come kind of all the way to this point where Systemd has all of these wonderful features, and they're worth using. There's things that you should use because they are so well integrated, because they are so usable. I'd also like to point out, since we now have Systemd running before and after the kernel, I think we can argue that Systemd is in fact a sandwich with the kernel as the filling. I don't know, maybe you disagree, but I think it's just as much a sandwich as this one is. So now we're on to the last bit, where I'm going to talk about Systemd running containers. So this is the bit that's most relevant to this CoreOS Fest at all. I'm not sure why they let me talk without talking about Kubernetes, so I'll at least talk about containers. Containers, well, you know what running containers looks like. Here's a basic example. This is, if I can click that play button, this is, I want to run nginx in a Docker container. Okay, cool. So you write something like this, and you use the features of forwarding a port and bind mounting a directory to be able to serve that file using nginx. Okay, cool. What about with Systemd? Well, with Systemd, you actually have a container runtime too. Systemd ships nspawn, which is a container runtime. I'd argue it replaces LXC. Some people might disagree. And this is a, whoops, let me go back a second there. This has a lot of the features that you might expect of a container runtime. For example, the first thing I do here is I type machine control pull tar. Sounds maybe a little bit like Docker pull. It also, for a very brief moment, supported machine control pull Docker, which actually downloaded unmodified Docker images from unmodified Docker registries. Good luck trying to revive that code or make it work again, because it was a wonderful pile of C, and I'm pretty sure that's why they deleted it. A wonderful pile of C interacting with a wonderful Docker API that changed a little too often. So we pull that down. We can now view the image in our local image cache and see, yep, it's there. It got mounted as a Btrfs subvolume, actually, because Systemd cares about your file system usage and wants to save some of it. And then I can download an nspawn file that looks very much like that Docker run command line, in that we just say, let's bind mount this directory, and then let's forward this port 80 right there. And now that we've got that nspawn file, all we have to do is type systemd nspawn and reference that machine name. Say we want to run the machine that we just wrote an nspawn file for. And a second later, we'll have our service running nspawn, running the container. We'll be able to look at the journal and see that it, in fact, is running systemd inside of that container. That systemd inside of the container is what actually will start start the nginx process. And then the nginx process is working, and port forwarding is working, and everything is as you might expect. Wonderful, right? You can also then do the sort of usual expected things. You can start up a shell. If you missed that, it was machine control list and machine control shell, which together, whoops. Well, machine control list and machine control shell, which will let you view all of your current containers and then open shells in them, play around. And you can see that basically you end up with something kind of like the Docker run command we just did, except all systemd. There's one problem. That was actually a lot of commands. That's actually kind of hard to type. Fortunately, we have Rocket, which if we type a similar sort of command in Rocket, here we're just typing rocket run, and then we've got here the volume option and then the port option. If we type that and we look at what we actually get, it turns out that you look at the logs and you'll see, wait for it, there we go, that it actually ran systemd inside the container, just as before, and then that thing actually ran nginx. It's suspiciously similar to nspawn, and that's actually because Rocket is really just a wrapper around nspawn and systemd at the time of writing. And you end up with something that gets you the same place just as easily, or perhaps more easily than some of the other container runtimes. However, we're not done yet. We're still running containers with systemd here. So systemd has nspawn. It has a wonderful container runtime there. And systemd also has service files, which are another way of running things. It turns out that systemd service files, as of late, have started getting more and more features that are very reminiscent of containers. For example, here, we have this root directory bit, where I'm saying, I want to run as if my root directory is here. And if you combine that with mount API virtual file system, that actually gives you a full mount namespace, just as you would get with a container. Similarly, the mount API VFS flag will give you these usual things that you get automatically mounted for you in containers. You can even create a network namespace. And then the final feature added in systemd 233 of bind paths lets you do that exact same volume mount we were doing a second ago in just the systemd unit. So you don't actually even need nspawn to create a container. You can just apply these options to regular old unit files and end up with something fairly similar. And as a reminder, this is a container Linux host, so there isn't Nginx on the actual host, but here we're able to run it, and it looks like we're running user sbin Nginx because that's actually what's happening inside the container. There is one problem. Unfortunately, even though we created a network namespace, networking still doesn't really work because it turns out we don't have a VETH bridge. Fortunately, there's a project called CNI, which someone talked about earlier, which does exactly this. It's obviously trivial to use, so you as the audience can use it. The real reason is I tried to use it, and it's not in this demo because I couldn't get it to work in time. But yeah, so systemd running containers. Woo. So here's a little bit of bonus random things you can do with systemd. While I was writing this presentation, I spent some time trying to figure out if I could make systemd Turing complete. And I couldn't figure out how to do it, but my first approach was to try and break systemd cycle detection by spawning a systemd process from systemd itself. It turned out this was a mistake. My machine, a few moments after trying this, ended up looking exactly like this. Every single one of those is a systemd process. This is also I found out that system control status will actually eventually quit making a tree when you have too many processes. I recommend not doing this. This is definitely something not to do. Something else I recommend not doing, because I realized that I'd crashed my system with systemd, I thought maybe there's a more efficient way to do this. This is the most efficient way I've found to create a fork bomb entirely with systemd and the systemd command line tools. Finally, I'm going to take a brief moment to talk about some of the direction of systemd, some of the things that it's going towards. So first of all, it's making regular users' lives easier. I've said that a few times, but basically systemd is replacing some of the old crufty Unix utilities with easier to use variants or with things that are more integrated. They almost always have better documentation. They almost always have a better user experience. I personally see this as an awesome thing, and it makes it a lot easier for people building distributions as well. This is part of why Container Linux uses systemd so heavily. One other thing systemd does really well is integrate well with containers. We saw that it can run containers itself, but even if it's not running them, it integrates with other container runtimes quite well. Machine control is able to interact with various container runtimes like Rocket, even if you're using the LXC containers, they work that way, or if you're creating them with libvirtd and you're using any of those sorts of container runtime interfaces it supports, then you end up with machine control working just as before. One other thing systemd has been looking at recently is portable services. I'm not the right person to talk about this because it's very much an experimental thing that Leonard Pottering is playing around with, but it might be something that systemd ends up doing, and it's something that I personally think looks really cool and looks like it might be promising. Think kind of flat-packed, but systemd, but for system services. We'll see if it actually pans out as anything. With that, thank you very much for attending my talk. I appreciate it. And if any of you have any questions or have anything that you'd like to ask me about, please feel free. The slides are available there if you so desire.
So you said the systemd can kind of replace Rocket, or not Rocket, LXC. How does systemd handle like templates or images?
Sorry, can you repeat the question?
How does systemd handle like templates or images? Or templates?
How does systemd handle templating?
Yeah.
Okay, so in systemd, you can reference environment variables using a sort of familiar syntax in your service files. And those environment variables, if they are set with environment equals or with environment file, will end up getting sort of substituted in. You can, of course, build your own templating on top and end up passing the files to it in the end if you really want. But in many cases, just being able to substitute in environment variables with the usual sort of $ curly brace thing will be enough. There are some weird things you can do. For example, if you need a unit to reference an environment file, it writes itself. That's non-trivial, and you usually end up having 2 units to do that, where they're ordered using its dependency management. If you want an example of how you can use this in practice, the Container Linux distribution ships something called the CoreOS Metadata service, which does things like write your private IP and public IP if you're on EC2 or whatever. And then we also have documentation that shows you, using that service, how you can reference it in other files and template in, here's my public IP, here's my private IP, and so on. Hopefully that answers the question.
Let me squeeze my, sorry. He's,
I might have misunderstood the question. Can you repeat?
Or something like that. So there's a rootfs like associated with those templates.
Oh.
So how do you handle, like, is there like a repository in systemd that keeps track of different types of images for each container, or?
Okay, so I guess the question is identification of like different container images and how you might interact with them?
Yeah, like, does systemd have like a repository for them? Or?
As far as I know, there is no centralized repository of container images for systemd.
Okay.
The closest you get right now is unfortunately Docker images with Rocket. It would be nice if systemd nspawn containers were a little more popularized. Yeah, sorry for misunderstanding your question the first time. Someone else at the back, or someone else over here?
Hi, I'm Clint Byram, co-author of the Upstart Cookbook and reluctant welcomer of our new systemd overlords. I'm just curious if you think there's anywhere that systemd should go that it isn't or hasn't yet. Is there anything that it doesn't find delicious?
That's a very good question. I think it's very much up for debate whether doing container management is a correct or incorrect thing for it to head into. Portable services is also up for debate there. In my personal opinion, I think that everywhere it's ventured so far has ended up working out well, and I really trust the systemd team to practice very good judgment. So once it hits something where it shouldn't go, I'll know it when I see it. I guess they've hit a couple things where they know they shouldn't go. The 2 easy examples being pulling Docker images. They realized that tracking an external software repository that was moving that quickly was not a good thing for a core system service. Like, they couldn't keep compatibility. They broke way too often by doing that. And separately, they created systemd consold, which they later backed out on doing because replacing Getty was a little too hard. With the actual reason they gave was that handling Unicode ended up being harder than they thought, so they gave up on making that bit. I still think that actually doing console management would be appropriate if they went back and did that. I don't know. I think that it depends on how it's implemented and on the systemd authors, and I trust a lot what they've been doing. So.
Hey, earlier you mentioned using the systemd remote setting for doing remote logging. How, in your experience, does that hold up against something else like the traditional ELK stack with Elasticsearch and piping logs to somewhere centralized where people can see them for?
Yeah, sure. So I say that this replaces use cases where before you might have used Syslog's remote logging, which is typically for smaller, dozens of machines, not something quite as big as you need an ELK stack for. You can, of course, use the ELK stack for any of those, but anywhere where you actually need the ELK stack, where you actually have that much data, systemd journal remote probably isn't the best tool. It's possible with enough work you can make it work, but the main benefit of it is that it works so easily with so little configuration. So it's really best fit for small numbers of machines, for like home lab or lower traffic machines or that sort of thing. So I'd say if you are using an ELK stack, that's probably a better place to be than this if you're at the scale where you need it. Hopefully that answers.
So systemd has a mount, so it supports volume mounts, so it can take advantage of like service dependencies and stuff, which is great. But under the documentation, they mention that etc fstab is still the preferred method. Do you know why that is?
I'm not going to speculate too much. It's possible because other utilities like mount itself parse those places as well. I will say that systemd actually automatically creates mount units from anything in fstab itself by parsing it itself. But I'm not going to comment on that documentation since I am not familiar. Sorry?
Yes. So everything you showed from starting a container with systemd seems very aligned with the Open Container Initiative. I don't know if that's what you are following as a standard or.
I'm familiar with OCI, yes.
Oh, you are following that to implement the container.
So, as far as I know, systemd has not expressed intent, or I haven't seen any actual work around implementing OCI, nor whether anyone on systemd has said they would want to. I personally think it would be awesome. It would be basically pull Docker as it should have been, something that actually references a real standard, not just whatever this registry code does. Unfortunately, the OCI standard also, correct me if I'm wrong, is still RC, still not actually complete, and doesn't define a full registry spec, so there's that. But I personally would think it would be awesome if systemd could implement that. And perhaps someone here, or perhaps I, would want to contribute time to that. Anyone else?
Hi. So with systemd implementing a lot of a container runtime, do you think we'll see anything like systemd naties?
I'm somewhat involved in the Kubernetes ecosystem. I also have not seen anyone intending to make that a reality. Really?
There is a runtime that's supposed to start.
Amazing.
Okay.
It's not out yet, but some people have suggested it.
Okay.
Awesome.
I am wrong. There's apparently people trying to make that happen, which, woo, that'll be interesting. Cool. Thank you very much again, everyone.